Okay, so now we're going to talk about solving differential equations. So if you ever see a problem like this one, and it tells you to solve the differential equation, what it's actually asking you to do is to find the original equation. So here, dy over dx equals x plus 3. So the first step to solving differential equations is that you have to match up the variables. So here we see a dy, but there's no x here, so it's just going to be a dy. And here we see a dx on this side and a dx on this side. So we're going to have to move this dx over here to separate the two variables. So the first step, dy equals x plus 3 dx, right? Okay, so now the second step to solving a differential equation is to take the antiderivative of both sides. And that makes sense because we're working backwards. We're trying to find the original equation. So, antiderivative of dy over y and antiderivative of x plus 3 dx. So this side, you can think of it as 1 dy. Oh, that's a weird d. 1 dy, and so the antiderivative of 1 is simply y. So that side's y. Here, x plus 3 should also be a pretty easy one to antiderive because the antiderivative of x is x squared divided by 2. You take the derivative of this, you'll get x, and then 3 is plus 3x. So that's how you do it. This is solving the differential equation. You found it. If you take the derivative of this, you'll get this. I forgot c, plus c. Basically, this is how you do this. Now let's try one where we don't have a x here. Let's say we have y plus 3. Okay, so now we have a dy here and a y here, and a dx here, but no dx anywhere. So what we're going to have to do is, I'm going to choose this side to be the y side and this side to be the x side. So I multiply by dx. So dy equals y plus 3 dx. But in this problem, you have to move the y over. But you also have to move y plus 3, because you can't just divide by y, because it just doesn't work that way. So you get dy divided by y plus 3 equals dx. Now like that last problem, we're going to antiderive both sides again. Antiderivative of dy over y plus 3 and antiderivative of dx. So here, we can use substitution. So if u is going to be y plus 3, then du is going to be just dy. So we plug in u. 1 over u equals antiderivative of dx. Now, the antiderivative of 1 over u is always going to be ln of u. So ln of, you have to put the absolute value bars here, of y plus 3 equals dx. So with dx you can use, like in the last problem, where it's just 1 dx, and then the antiderivative of that is just x. So now we have ln y plus 3 equals x. So you could leave it this way, or you could raise both sides to the, e of everything to that. I don't know how to describe it. You do that. E to the x. I keep forgetting the c. Oof. So e to ln of y plus 3 is just going to be y plus 3, because these two are going to cancel each other out. So y plus 3 equals e to the x plus c. Now, you see this plus c, we don't really like that plus c, so what we're going to do is we're going to use the exponents rule that you can just do this. This is the same thing as this. You can just move it from these two. And this e to the c, we're just going to call that c, because this is still just going to be a constant. So c times e to the x, and we have this 3 here, so y equals c to the ex minus 3. So this would be solving for the differential equation, and you can see that if you have a y here, it's going to be a little bit harder to solve than if you were to have an x here, but you can still do it.